So what are we going to do today? When we look at building the applications, any stuff on Google or any other cloud, I'm not even talking about some of the other clouds, specifically on Google Cloud. And you look at different options when you go in the console, right? And you find, hey, there is Compute Engine, there is App Engine, there is Cloud Run, and few other services. And then you feel like a bit overwhelmed, and sometimes you feel like a bit lost. Hey, which service do I use for my specific use case? So I'll try and help out to sort of lay out what are some of the things that you should be considering when you are looking at the right service, the right tool for your particular application. So welcome, everyone. Really appreciate your time today. All right, so what's the core challenge? We are going to build a Minecraft server. We need to build a Minecraft server on Google Cloud. But before we even start, this is like all these small Lego pieces that's in front of us. The challenge is, hey, which block do I pick? Where do I start? How do I make the right choice so that I pick the right tool for the right functionality of my application? How many of you here have had instances when you go to your organization, or there have been instances when you have an application running and you really ask either yourself or someone, hey, why was it done this way? And then you get the answer, this is how it was built, so this is how we are building it. And you feel like, hey, but it looks complex. Hey, it is costing us way more than it should be. Hey, this is not really the particular use case for what we are trying to do. This is not really the right tool set. This is pretty much what happened, right? So we have a set of blocks in front of us, then someone comes in. They feel like this is the right block for this one based on their experience and based on how they have built the Lego pieces or a server in past, and then they just pick the block. So I'm no different. Okay. So looks like I'll have to switch between the tabs again. Now, when we talk about Google Cloud, and again, I was saying this, I'm not even talking about some other cloud platforms wherein the number of services that are offered for a particular stuff that can be done is numerous. But if I want to build a server, as I was saying, there are quite a few different options. So many blocks. We have Cloud Run. We have GKE. Even in GKE, we have Autopilot and Standard. We have Compute Engine. We have App Engine. We have Firebase, and maybe many, many, many more. Now, if you talk to people from different backgrounds, if you talk to a developer, he will be like, hey, just use Cloud Run. Why to bother about any of the other stuff? If you talk about SREs, they're like, go GKE, build your own cluster. But if you talk to any of the person who comes from a sysadmin background, who wants to and who likes to have total control on how the servers are run, what kind of patch level or OS level that's running on the server, they'll be like, use Compute Engine. That's the thing that gives you the complete visibility, complete control, and the best security. But is that the right way? Is that the right approach to choose the tool? Let's figure out. Now, before we even start talking about which service is the best for building a Minecraft server, let's take a step back and look at our use case. What are we trying to achieve here? What are we trying to build? On a very base level, at a very fundamental level, my only goal is to build a Minecraft server using Java. There are two main requirements that I need to look at. Obviously, there are a few more, but fundamentally, there are two main requirements. I need the server to be stateful. We'll talk about that, why I need a stateful server. And then I need a custom port. I don't need the default port or any HTTP, HTTPS port. I need a custom port. So I want to build this home for our own world with these two main requirements. So as a developer, when you go to Google Cloud and you look at different options or different services that are available, so what are the few services? As I said, there are multiple, including App Engine, Firebase, and all that stuff. But for our particular use case, if you look at the documentations, Firebase, probably not. This is not really the right service or tool to build a server. Similarly, for App Engine is where you just want to write the code. You don't want to host any server, or you don't want to manage things. So typically, for this particular case, the featured blocks that are available for us to use is Cloud Run. Cloud Run, it is stateless, event-driven, scalable. Scalable is the key thing here for Cloud Run, right? People, especially developers, they like the capability of Cloud Run to scale down to 0. You don't pay for anything if you're not using the service. Then we have GKE. Even in GKE, we have GKE Autopilot and GKE standards. So we'll talk about those things and the kind of arguments that you can have when you're looking at whether I should go for GKE standard or GKE Autopilot. So how many here have used Kubernetes or GKE? Quite a few, again. So GKE provides you the statefulness for your applications. It is quite powerful. It is resilient if configured the right way. And obviously, it gives you a lot of control over how you configure the networking for your applications. Then we have the sort of old is gold kind of thing, compute engine, right? So you have the complete control over how you run your application. With the evolution of cloud, it even helps you with the constraint that we used to see previously in terms of scalability. Now you can have instance templates, and you can create a sort of virtualization at the top, and you can have multiple instance templates underlined, and then you don't really have to worry about the scaling and those sort of things. Is that all? Maybe not. Let's look at Vertex AI, right? How can I deliver a talk even without talking about AI? That's the main feature. That's the main tool that we can use to enhance the capabilities, to give our end users more features and improve the functionality and the efficiency of the server or the application that you're building. So we'll see how we can make use of Vertex AI when we are developing Minecraft server. All right, so first of the list, let's meet Redstone, our Cloud Run server. Why is it Redstone? Let's take a look. It is simple. So how many of you have used Cloud Run in past? Okay, few. It is very simple, right? So you don't really have to worry about the underlying infrastructure, which network it should go to, how my servers should look like. All you have to worry about your code, the application code, mostly, right? And if at all there is a discussion around the private connectivity or making your instances private, there are other options. But obviously, you'll need a bit of involvement from the networking side. But it is comparatively very simple. It is fully automated, so you don't really have to manually work out the scaling up or scaling down of the instances or the services that run on Cloud Run. It is fully automated. And as I was saying, if there is no traffic, if there is no one using your application or hitting the endpoints for your application, it scales down all the way to 0. So you don't pay anything. And it is very efficient. Now, it sounds really good. Now, being a developer, I think this will be my go-to service. So I'm a developer, right? So as a developer, we love the efficiency and simplicity. So our first instinct would be just go with the Redstone on Google Cloud Run. So the advantages are really obvious, as we saw. So it is incredibly simple and fast to deploy because it is very lightweight. You can deploy a container from a single command in under a minute or maybe in a couple of minutes, right? So it doesn't take that long. Most importantly, if no one is playing the game, you don't pay anything. It scales down to all the way 0 instances. But now, before taking a call, before saying, hey, this is the best tool, this is the best service that I have for building my Minecraft server, let's do a litmus test on this. So we will do Redstone test. Let's take a look at some pros and cons and our specific use cases. So pros, yes, it is really very fast deployments. It does scale up and down automatically, so auto scaling. And it is very, very cheap. Specifically, if there are less users or no users at all, we don't pay that much, or we pay 0 for specifically the compute. However, if I look at my requirements that we discussed initially, one of my requirement was around statefulness. Cloud Run, as such, in itself is a stateless service. What I mean by stateless? When the instance terminates, you lose your world, right? So it doesn't provide you a capability natively to keep state. There are ways you can create other storage solutions that you can integrate with Cloud Run to keep a state, right? So you can have options. You can have different databases where you can keep the state. But again, we are looking at what is best suited for our use case, right? So this is something that we'll have to look. Is it the cost that is being added, or is it a complexity by introducing another service or another instance to store the state? We'll take a look. The other requirement was to have a custom port, because I don't want to run my server on a default HTTP or HTTPS port. I want to have a custom TCP IP port for my particular server. That's again a constraint for when we look at Cloud Run to spin up our Minecraft server. It is ideal, Cloud Runs are ideal for running short-term requests. So that's the reason why it is called as an event-driven service. So what I mean by that, you tell the instance, hey, there is a request, there is a specific task that you need to do, you need to perform, and it goes there, does the task, and either just terminate or it moves on to the next one. So it is not really ideal. It is not well suited for long-running instances, long-running use cases. So while Cloud Run is amazing, now if I look at all the requirements that I had, so it is cost-effective for running my compute for the server. It is very, very effective, very, very good if you are looking at the API use cases, if you want to create some sort of microservices things. It is fundamentally not the right choice for our particular use case for 2 reasons, right? So one is the statefulness or the complexity that we'll have to introduce, or maybe the cost that we'll have to introduce to make it stateful architecture or a stateful solution. So what's our next choice? Now, after looking at the requirements that we had, we said, okay, maybe Cloud Run or the Redstone is not really the right choice. So Redstone is good to create some short sort of circuits, but probably not the right choice to build the foundation of our house, or the laying down the foundational layer of our house. What's the next block in the collection? So let me introduce the Iron Pickaxe. So we have the traditional compute engine from the list to choose from. We have the full control. We can control the OS or the ports that we manage on compute instance. it is going to be persistent because we can attach a physical drive. We can manage the speed by attaching a SSD or hard drives accordingly based on what the requirements are. And then it is reliable. So feels like, okay, we are almost there. We have compute engine that is meeting most of our requirements. So if Redstone is not really the right choice, if the serverless thing busted, it's not fitting the tick boxes or the requirements for us. So let's move on to compute engine. And yes, it works perfectly fine. So we have control. We can open up the TCP/IP ports. It is customization friendly, so we can customize pretty much everything that we want. The servers is up and running, and as I was saying, from a scalability point of view as well, so it doesn't have those limitations. I can spin up under a load balancer multiple instance templates, and it can handle the auto scaling. Now, before I take a call on that, let's do a test again on the Iron Pickaxe. So if we look at some of the pros, so it has given us full OS control. It gives us that statefulness by providing us the persistent storage. And we can have custom networking. We can open up the TCP/IP ports of our own choice. But if you look at the operational overhead, right? So you are now the system administrator. So it is not just a bunch of servers running in the environment. You have to manage all of these because this is not really managed service. This is not being managed by the infrastructure provider here, which is Google Cloud in this case. So you are the system administrator. It means you are responsible for all the patching, security, hardening, and all those sort of things. And that has to be managed all by yourself. Another complexity is, or another thing that you need to take into account is always on cost, because it is always running. No matter if you're using it or not, if you have 3 instances as part of your managed instance group that are running, you are paying for all the 3 servers, even if there is only 1 user, 10 users, or maybe none using your server at that particular time, be it 3 a.m. or 3 p.m., you're paying for the same set of servers all the time, right? And finally, resilience. Resilience, it's quite manual. So no built-in scaling. So unlike Cloud Run, where we had the automatic scaling option wherein it will scale up and scale down all by itself based on the traffic that's coming in, you don't really have that here. So while compute engine is solid, right? It gives you that control over how you want to configure the networking, how you want to configure the ports, and also the statefulness. Is it the right choice? No. Why? Because it doesn't give us, if I look at the requirements, yes, it fulfills all my requirements from a statefulness and the custom port perspective. However, there's a lot of manual labor work that's involved, right? So it is a lot of operational overhead. And if I look at this commercially, I have a lot of people working on maintaining that particular set of servers. So it doesn't really fit in my particular use case from a complexity cost perspective. It does meet all my requirements, but it's turning out to be a bit more expensive and also complex. So let's move on. What do we have next? Introducing Diamond Pickaxe, which is Kubernetes engine. So GKE is a managed Kubernetes engine service that's provided by Google. So when I say managed Kubernetes service, so depending on whether you are going standard or autopilot, Google manages a lot of stuff that is introduced from a Kubernetes point of view in terms of control planes and a lot of internal services and internal functionalities. So Google manages some or most part of it, again, depending on whether you're going standard and autopilot. And you are only responsible of managing the workloads, the containers or the pods that are created on your cluster. So how you run it. So it is quite robust because it has servers robust, and it also takes care of the resilience and the networking part in the background, because it has failover instances as well. So if one particular node fails, there are other nodes that can take care of your workload at all time. It is quite powerful in terms of scaling, in terms of handling your workload. No matter how much workload you introduce on your server or on your cluster, it can, just like Cloud Run, there is a bit of configuration that's needed if you're using standard, but it can scale all the way up to like hundreds or thousands of nodes and pods, and it can scale down quite significantly as well if there is no workload. And it is durable. See, it sounds like it is probably the right choice. Now, we can't really confirm that again before we run the test on our Diamond Pickaxe. So let's figure it out. It is stateful. That meets our requirement. You have the network control, right? So you can configure which network it should sit in, how your pods are configured, how the traffic to your pods or the other control planes are managed. So you have all that flexibility. It is highly scalable, resilient, and automated operations. Now, what kind of automation or what level of automation you really need? There are options. So there are, if you are someone who feels like, no, I want to manage the whole end-to-end operations of my cluster nodes or the control plane, you get that option with the standard. But again, you need to put that hat on from a like end user perspective. It's not really about, hey, I am a Kubernetes guru, I know Kubernetes in and out, but it's more about, do you really need that? Do you really need to take control of some of the complexities that are introduced when you are managing your Kubernetes control plane yourself? Or let Google handle all the complex stuff and you just go for autopilot. And one of the great things with autopilot is, and when I checked it out, I was a bit surprised that unless, and it is pretty much like an extension to Cloud Run, unless you start spinning up the workload on your autopilot cluster, it doesn't even spin up the cluster nodes, the control plane nodes. So you are pretty much paying nothing unless you have the pods or the actual workers running on the cluster. But when you do, you have the control plane and you can configure whatever way in terms of networking or the custom ports the way you want. And then you can also at the same time enjoy the flexibility of the same sort of flexibility in terms of control that Compute Engine provides, but at the same time, automation and manageability becomes very similar, very easy from a management overhead perspective, similar to Cloud Run. But again, there are a few call outs, right? So it's not that simple. There is a lot of learning curve, especially for people who don't really know Kubernetes well. I mean, it's not that difficult if you're managing your own cluster and your own servers, but there is still a bit of learning curve if you don't come from a like SRE background or if you don't know much about the Kubernetes cluster. So you need to understand the configuration complexities around how to configure the replica sets, the pods that are running, how to secure your inter-cluster pod communication, all those sort of things. There's a bit of cost overhead as compared to Cloud Run, but might not be as much as while you are running it on a Compute Engine. And obviously, as I was saying, configuration. So feels like, for now, yes, GKE Autopilot seems to be the right choice for me, right? Is that all? I have got the foundational layer now. I have the building blocks now. I know my house is going to be rock solid because I have laid the foundation. So when you develop any project, when you are working on, so there are two things, project and program. When you are looking at a program, there are multiple projects that you can look at. Now, I've got one project complete, which was to lay the foundations for my Minecraft server. Now, as part of the program, let's look at the next phase. So that was the strategic. Now look at the optimize. Optimize phase is when I look at, hey, how can I increase the functionality, efficiency, or how I can improve the user experience for people who are going to use my game server. That's where Vertex AI magic comes in. Enchanting Table. Now, let's look at how I can improve those functionalities in my Minecraft world. Again, these are some of the things that I think we can make use of Vertex AI to improve the efficiency and the functionality of my Minecraft server. Use cases can be completely different, again, depending on your background. If you are coming from a more of a SRE and those sort of sites, you can look at using the LLMs or the Gen AI functionalities from Vertex AI to automate some of your DevOps, the deployment pipelines, and all those sort of things. However, if you are coming from a product side, if you look at your application and you look at how I can improve the end user experience. So things like chat modernization, right? So you can use LLMs to detect toxicity in the kind of language, or you can put in a filter, hey, if there is a range of words being used in communication by the end users, throw up a warning so that you make it more friendly for everyone to use. It blocks user to use spam or slang languages or any of the not that civilized sort of words, right? Dynamic quests, so AI generates context-aware adventures. If you feel like, hey, there is a user who is playing like a pro, he's pretty good at some of the stuff, you generate a dynamic quest for them to complete, and then they get bonus points for that, right? So I know there are quite a few people who like to be competitive and they feel like, hey, we got this special badge, and they feel really, really special. So you can generate those sort of things. So when we hook that into our whole ecosystem, these are the kind of functionalities that we can add and we can offer to the end users. So I know we are almost at time, so just to quickly run, so crafting the right choice for your particular solution. Cloud Run, which is the Redstone in our case. So it's simple, stateless, event-driven, but it is best for the APIs and the microservices or webhooks or your websites. Compute Engine, which is the Iron Pickaxe in this case, it gives you full control, persistence, but it is mostly suited for legacy applications when you have specific OS needs. Kubernetes Engine, it is complex, but it gives you statefulness, high control, and resilience, and best suited for game servers, databases, or complex microservices. And then we bring in Vertex AI into the mix. It gives you a lot of added intelligence on top of your foundational layer for your applications. With that, I'll stop here. That's pretty much it. So this is me. My name is Anu. Feel free to connect. So I'm the founding director of Corex. Corex is a consulting company. We are a Google Cloud partner. I am also a GDE, Cloud and AI, and I'm an authorized Google Cloud trainer. And the hook, I also have a GKE Kubernetes Engine course on Code Cloud. People who are from DevOps background, you probably know Code Cloud. Code Cloud is an online learning platform. I've got a Kubernetes Engine course as well. So feel free to connect with me on LinkedIn. Thank you very much.